First of all, let me say thank you from SNAD for the scientific help on Apollo 16. I personally think that you all did a very credible job in helping the science support room and pre-flighting to get all the experiments ready, to prepare the crew and the flight for Apollo 16. I think that looking back on it now, we can say we had a very successful mission, that we attained a tremendous amount of information from the flight. I know that the rock boxes back there at the curatorial facility are bursting at their seams, and the geologists are going to have a lot to do. I think also that because of the problems that arose and the necessity to change the flight plan, that you responded quite well to get the maximum science out of the time that we had available. I realize that in all of our flights, there hasn't been one flight yet that ran according to schedule, and I am very sure that Apollo 17 will be in the same boat, that we will have to change things real time to get the maximum science out of the mission. And I think the response on this flight was superb. Now today, the briefing here is in two parts and for two purposes. First of all, I'd like each principal investigator to briefly describe the results so far obtained from his work. This is to sort of educate the crew on what we obtained so far from Apollo 16 so that they might have information along that line. Also, I'd like to have him describe any anomalies that might have occurred that we do not know about now. And second, then we'd like to have the PI with the crew working with them to have the crew answer any questions that might still be puzzling him so that he might further his analysis of the data. We have a lot of people to go through today, a lot of science to cover, so we'd like to keep each briefing short, and we don't want to cover things that are pretty well, that are general knowledge as of today. And we start right out. Let's see. First one is Palmer dial, lunar surface magnetometer.
I guess the main functions of both instruments went nominally. I'd like to cover both the portable and the surface, if that's acceptable. The ALSEP instrument, the surface magnetometer that you deployed first, looked like it went according to plan. The field that we measured as soon as it was turned on, I think it was turned on about 15 minutes or so after you deployed it, was 230 gamma and in a downward direction. And at that particular time, that was the highest field that we'd ever measured on the lunar surface. The calibration of the instrument went straightforward. We did do a gradient determination of the field at the site. The site survey, as we call it, functioned normally. Its thermal control subsystem is the best that we've put on the moon so far. We have a delta T from lunar day to lunar night of 51 degrees centigrade, which is a factor of 2 better than our Apollo 12 thermal subsystem. The leveling of the device was, I noticed in the photograph yesterday that the bubble level was right in the center ring. The level sensors that we have are accurate to 1/4 of a degree, and they show that that the instrument is level to 1 degree accuracy right now. The instrument has new sensors in it. These are more stable, and it's really the first chance we have of doing network type measurements of the fields on the moon. We do see whole moon, we have seen simultaneous data now from 15 and 16. We see the magnetic fields due to eddy currents that are driven in the entire lunar sphere, and for the first time experimentally, we've always made that assumption that we've got an instrument that's setting on at one point on a sphere and that we're looking at the properties of the whole sphere. And we had some experimental evidence that that was the case. Now we have unambiguously shown with this second instrument that that is indeed the case, and that the assumption is correct that we are looking at a whole spherical response of the moon.
You mean you're seeing eddy currents all the way through the moon, huh?
We're seeing eddy currents that travel around the whole sphere, but with these new sensors now and with long-term data, what we're going to try and do is look, as you say, right at the center of the moon as they go all the way through. Now that's what we're waiting for during the lunar night is a nice step function and a long-term, both before and after, so we can see these currents diffuse right through the center of the moon. The other thing that I think that is unique about this instrument that now we have a chance to look at the azimuthal variations in conductivity. We can not only look at radial dependence of the electrical conductivity and calculate a temperature, but now we can look at the azimuthal or angular variations between Apollo 15 and Apollo 16 side. And that spread is far enough so that we ought to be able to extrapolate those measurements to a great circle around the whole moon as far as azimuthal dependence. The portable magnetometer was really exciting. First of all, the first field I think you measured was 180 gamma down, and in the Cayley it looked like that all the fields were in essence pointed in a downward direction, and at the Alcep side it was 230 gamma, up near Spook it was 180 gamma, and then on the other side of the LEM where you parked the rover at the last station, it was 120 gamma. And at that station you put a rock on it, and it looks like we measured about 4.7 gamma from that rock. So the rock was large enough and had a large enough moment that it looks like we did see a difference. And these measurements do have an error bar on them that is like plus or minus as much now as 5 to 10 gamma, because the solar wind and all the other inductive fields that are around that have to be subtracted out of the measurements from our from the tape and data reduction.
Do you have any questions you want to ask the crew concerning anything about the deployment or anything of the experiment that you don't know about?
Palmer, let me ask you, what is the effect of that rock out there by the big LSM? Did that hurt it much?
No. First, where you parked the rover the first time in the TV camera, we were extremely disturbed because the angle was such it looked like that rock was as big as the electronics box, and it looks like that the PRAs were oriented so it was shining right into them, and all the IR radiation would really heat us up during the daytime. But then the other view showed that the rock was relatively small compared to the dimensions of the box, and it didn't affect the thermal subsystem at all. And magnetically it didn't, they really don't contain that much oriented field to do anything.
I guess one of the things I'd like to say is that what we intended to do was we intended to drive 100 yards away from out in front of the lunar module with a rover and do a sort of a north-south traverse looking for the best place to deploy Alcep to get it away from all these things. We ran into problems with a UV in that it took longer to do that last measurements than anticipated, and we couldn't do that. And I'm sure that somebody looking at the photos can find a better place out in front of the lunar module to put the total package. But I like to say that package is so big and that surface was so blocky and so full of craters that under the circumstances I almost believe we had to take what we got. I hate to say that, but man, I just wouldn't believe that surface was as rough and as covered with blocks as it turned out to be.
I think I could have still been walking up there with that package if I'd have been looking for a level spot. I got up on top of the ridge and I looked over and said, well, there's a good place over there, and I ran over there, and it didn't look any better than the place I'd just been, and well, there's a good place over there, and I ran over there, and finally after about the third time I said, well, look, I'm just going to put this thing down here at best we got. But it's really blocky and a lot of fresh craters there, secondary.
Well, but I think that If you look at at least the magnetometers, I looked at each of the photos that I could find where you'd taken a picture of both the ALSEP magnetometer and the portable. You picked, you didn't put the thing next to rocks or craters on a scale size that was big enough to affect the instrument. I think that's the main criteria which was observed during that.
John, did you know the rationale for doing that unplanned portable magnetometer reading?
No, but it doesn't make any difference. I mean, we did it. You can explain it in real time. That's all right.
On the hardware, the sun shield on the LSM, the latch didn't come loose, and I kept pulling the arms up to try to get that latch loose, and I finally had to hold the arm down and get the latch loose with the other hand. And then as I tried to lock the thing, the latch didn't fall off. It tangled up into that little wire that locks into the little ball.
Yes.
And that was I almost left it like that without locking it. And in fact, Houston said, go ahead and leave it. But with one more little effort, the thing finally dropped off. And I thought I was going to disturb the level, but if you seem like you're satisfied with the level, because
yeah, the only thing I worry about there is that we've got a level sensor in the thing, and if you disturb that, you can sort of see that jiggle. But the azimuth, you know, when you read that shadow graph off, that's the only measurement we get in azimuth ever.
yeah.
And so as long as you didn't disturb the twisting of it, then it's fine.
Okay, thank you, Palmer. If there are any questions at the floor at any time after the discussion, feel free, just raise your hand.
Our fun began, as you know, with the S4B impact on this mission. You also know we lost tracking on it prematurely, which meant that we were not able to get the coordinates and time of the impact independent of our own measurements. Nevertheless, we could locate it fairly well from the two near stations, 12 and 14, which made it a useful impact at the greater range up to station 15. And we're looking at those signals now. I think we can say that this peculiarly high velocity mantle, as we called it, that we had found in the 12 and 14 region can't be a global feature unless it is
a very shallow crater that had a Hackley black blast right in the center of these little craters. And the biggest one was no more than 2 meters in.
You see down in the plum, see that outline of rocks down in there? Down, no, keep going down.
Right here?
Right, no, over here.
Well, if you point to it.
Okay. See those rocks right in there? Well, I think...
near the bottom of the
yeah,
view.
I wouldn't be surprised, but what the most likely candidate for a rock that was from down either in the bottom of Plum or from the lower part of Flag was that piece of rock that we chipped off of.
It's located right in this area.
Yeah, it's
here.
just outside of the
Just
view
out
of this picture.
And because that had been, that was well under it was a submerged rock, and I got the feeling that it was sort of local to the area. I mean, I don't see how it could have been from South Ray or unless that was extremely soft when it plunked in there. I didn't rule out that, but I mean, that would be the most likely candidate of the ones we could get to. We could no way we could have got down in there and got those rocks.
That's true.
And gotten back.
Since they took your tether away from you, I don't imagine you want to explore those craters. Okay, the Buster crater, photo 8, please. This is your partial pan of Buster. Again, not a winner for photographic work. It's at least as good as the astrologer's pictures, though. You described that there was a southwest and northeast boulder field in here. We're looking almost down the sun, and I'm wondering, I can't tell in these photographs, could you tell whether there are blocks over in there, and therefore your impression of this streak
Well,
across it could not be salted because you're looking down sun.
well, I might have been. I didn't really mean to say southeast northwest. The predominance of blocks in Buster were oriented in this direction, across out this way, which is northeast southwest.
Yeah,
And
that's what you said.
yeah.
And you're reconfirming that.
Reconfirm that, and over in this area, there you can see some of the blocks, but not nearly as many as here. Now, we can barely see the bottom of Buster, but the bottom of Buster is covered with blocks that were up to 2 meters across and showed no orientation in any direction. My feeling over in here, due to there were blocks in this area, but they were not as numerous as this pattern in here.
And so the blocks that you're on the side you were standing would have been derived primarily from that hole and not from the impacting material. That it has the appearance of a secondary from South Ray in this kind of a photograph.
Sure
and the
does.
description of it. Do you not go with that interpretation?
Well, if it is, it's the biggest one
It's a
we
biggie.
saw. That is a big crater. From here to here was at least 50 meters.
At least, yeah.
And the size of those blocks and the depth of that crater, and South Ray is 6 kilometers away. That had to be one big block that pounded into there. And I don't know whether you can even excavate something that large from that
It's
distance.
much too large to be.
I don't really think it's a secondary,
Yeah,
personally.
that's
So
my
we're
feeling
looking-
that looking at it, it was a primary, because I couldn't conceive of how you get one from, of course, it could have maybe been a secondary from one of those big craters way down south. That's a possibility.
So that's either local bedrock or some of the flap or the thrown out material from Spook that we're seeing there in the floor and the walls. Great.
Spook
Well, I'll
didn't
tell
look
you,
like that at all. This was a lot fresher crater
I'd
than
hate to
Spook.
oversimplify this business, man, because it don't tell them where that rascal came from. I would think that because that rock was on a slope that went back up that way, that it's a good candidate for a permanently shattered sample, because when the sun got low enough to where it could shine down that gopher hole, well, it's probably behind that slope.
But-
You know, that's something we wanted to get a fairly accurate spot on so the guys with their sun angle stuff can turn that shadow around and know whether it really did stay. And
Well, this was a big overhang, Bill, and it was above my head, as you can see, and I had to bend over and put my hand into here and then reach up under, and the sun comes across
Yeah.
more to the north.
on the other side.
Yeah,
so
on the other side up in here.
it looks like a good shot, but the guys that'll be doing experiments on it would like to guess as to whether
Yeah.
it's a single day or forever. Great. Now, unfortunately, the film counting ran out, and so you didn't get any close-ups that we can find of the drill holes on this rock that you talked about.
Well, there's one here, there's one there, and there's some down in here, and there's one. They were all on this side of the rock, which is the east side, and they were circular.
South side.
That went into the rock and looked just like drill holes to me.
Just went straight in, roughly
Straight
normal
in.
to the surface.
Yep.
So that gives them a consistent orientation. That's interesting. That makes them sort of parallel to the layering, which you can see there dipping off to the right at about 30 degrees.
Yeah, you got the feeling they were like those things you find in volcanoes where the gas comes out through a single hole.
But they weren't vesicular in the hole. It was a
No
open hole.
No visible lining to the
No.
hole like some of the
Looked
rocks
just like
that
a
have
drill
been-
hole.
Huh. Okay, in other words, they aren't irregular. They're just straight as an arrow drill hole. Now, the photographic procedures we'd set up pre-mission for studying lineations didn't work too well because of the 3 rev delay and then sleeping first. But we've got some material that resembles earlier things, and I'd like to show you one slide. Slide 14, please, which was from Apollo 15. You guys have seen that one before. And now I'll show you, next slide please, 15, which has the same type of lines. And then slide 16, which is just to the right of this, that's crown that just disappeared off, and crown is at the very left edge of this. At the time you were describing these as resembling the ones from the 15 mission, and you said you couldn't really see them on the ground. The impression you get here is that you'd have major undulations that you'd be climbing up, and I would gather that, well, if you want to try amplifying any of these thoughts that you had, this is to the right of where you traversed up the mountain. Anything you could add beyond what you remembered, I have already said in the transcript.
I guess the major ones appeared to us as benches, but when we got in them, the little bitty ones, you just didn't, had no feel for it at all. I didn't.
My impression was then, and still is, that it is topographic in nature, and it's slight changes in the angle that the sun shines on those particles that causes those lineations. Now, why they're so continuous, I don't know. Maybe it's just that I don't know whether you can actually take one and track it all the way across the picture. That might be an interesting task for someone to do, but
I've tried it and you can't.
Well, when you get standing right in the middle of them, you sure can't.
You can't see them.
Can't see them.
Except that at Flag Crater, in that loosely compacted regolith, when we first got off, I think I took a close-up with a 70 millimeter, and there were thin pencil-like lineations that were almost cross-sun, maybe 30 degrees to the sun. So that'd make it northwest, southeast. Randomly oriented and only a couple inches long. And I got the feeling that it was all small scale due to the particles, the way the regolith was sitting in there loosely
just little
compacted,
hillocks that would make a
little
pencil
hillocks.
shadow.
And it was these particles, the sun casting a shadow, that caused those little fine lineations.
Do you mean rather than randomly oriented, randomly spaced?
Yeah,
on the
randomly
surface in that
spaced.
area?
Randomly spaced, and they were mostly oriented 30 degrees away from the sun line in the long dimension.
Good.
Ken might amplify something from orbit. Just about every crater that I looked into before we manned a limb, you could also see these lineations that were
Going diagonally into the craters.
Yeah.
Would that be the way they were?
I don't think you could say they're diagonally.
No.
I think the thing you can say is that if you ever found a place on the moon that didn't have these lineations, you'd find a very unique place.
Yeah.
But they aren't necessarily diagonal, and they do reflect surface expressions of other topographic features. They bend around small craters and big crater walls and things like that. And whether we're seeing always the same thing or whether there's several things that contribute to this effect, I can't sort that out.
Ken, could you see them from 60 nautical miles without the binoculars?
I would say no. I really don't remember offhand, but I think not, because it was so dramatic to me when we came down in the parking orbit that as we got closer to the surface, they started popping out, and they were very significant at 10 to 8 mile range, but I remember seeing them always, and I think it must have been using the binoculars that showed them up.
By always, do you mean the low sun angle parts of your orbits, or even at high sun azimuth?
Always.
Always.
Like I say, I have the feeling that if I ever found a place that didn't have that pattern, it would be very unique.
Mm-hmm.